kariRS, the ultimate embedded Rust framework for building robust real-world projects. So kariRS is basically a Rust-based embedded framework for microcontrollers. That means it is written and it is based on the Rust programming language. It is developed and maintained by Vincent Morelli-Karimi, and its official GitHub repo is as shown. It is hosted under Vincent Morelli kariRS. So the big question is, why kariRS? And to answer that, we need to go to the point of what do we currently have. So currently, if you want to enter into embedded space of building robotics and embedded systems, you have frameworks like Arduino, which are basically C++ based, and from there maybe you can write low-level code using C++ and Rust. But again, it creates a gap between people. It means if you are just a beginner, the only entry point, or you are limited to what you can start in. You cannot just be a beginner and go to Rust. The Rust requires you to have a certain deep understanding, and that's where kariRS comes in. We only, for a long time now, we've only had the option of Arduino because Arduino just did something amazing, that they have this model which is friendly to everyone, a professional or a beginner. And now we do not have that one in the Rust ecosystem, which is growing and gaining adoption in the embedded system space. So that's why we have kariRS. So kariRS basically takes all the low-level code and it gives you abstractions which are very beginner friendly and also advanced to help you build robust projects. So that's why we are saying, from the very moment we look at what embedded development involves, it involves unsafe low-level code, complex tool chains, boilerplate heavy project setup, and difficult learning curves. And that is what kariRS is coming to solve. It gives you high-level abstractions. Like for example, the same way when you look at Arduino, you want to toggle a pin on and off, just like something like digital light. That's the same thing kariRS offers you, but this one is much more safer and much more explicit in what you are doing, as it is based on the Rust programming language. And so kariRS is giving entry to people who are in Rust, also people who would like to shift to Rust, which is a very safer language. And this is the benefit and why kariRS has come up. It is the first embedded, fully fledged framework based on Rust, which is coming in the embedded space. And it is emerging as a tool that can be used by both professionals to build their real-world projects, by students at the universities, and it is really, really amazing. So kariRS was created to reduce this complexity while preserving control and performance. That means kariRS can still allow you can still write low-level code in kariRS, but you don't have to, because kariRS gives you the high-level abstraction APIs to be able to write your code in a much more explicit manner and safer manner. So we have the overview. So kariRS is Rust-based embedded framework, and as you know, Rust is a language which is offers and entails a lot of safety. It's a bit due to the borrow checker. It's a bit harder to have memory leaks because the Rust compiler is very strict on that, and kariRS being built on Rust enforces that level of safety for embedded systems, which require a lot of performance and safe code. And that is what kariRS is basically doing. And that's why we're saying that kariRS is a Rust-based embedded framework that provides, number one, a predictable execution model. The model of kariRS is very predictable and very easy to understand. It is also safe and high-level hardware abstractions. You don't need to know to write the low-level code of the registers and everything. You just have to deal with the kariRS high-level APIs and abstraction layers. You just have simple project configuration. Starting a kariRS project is very simple. You just type kariRS, or you use the kari command, and you write new, the name of your project, and the board that you want to set your project for. So it's very easy. When you look even at the documentation, it is well documented. Everything is quite easy to start with kariRS. It is indeed it's like a treasure to the embedded ecosystem. It also has a clear separation between APIs and internals. That means that the APIs you're using, it's hard for them to change. As the internals change, the APIs remain the same, and that creates a difference in concern about the kariRS, making it a framework that is reliable, that you can rely on. Based on that, you do not expect that tomorrow kariRS has changed a certain API to be different. No, it will still be the same, just the internals are changing and the implementation just changes, but the same API works the same for your code and under the various versions. So that's the predictability and the reliability that kariRS offers. It focuses on clarity, safety, and consistency. When you look at kariRS, it is quite safe. It requires that a lot of things in kariRS are type checked. You have to like explicit say what this type of, if it is a, for example, if it is a digital output pin or a digital input pin, you cannot initialize it as just an input. If it is a digital, you have to initialize it at digital input. You have to say it's an input digital, and if it is an input analog, you have to say it's an input analog. Unlike in other frameworks like Arduino, where you just write output or input, in kariRS you have to be explicit, and this creates a much more safer ecosystem when you're writing the code for your embedded. So next is look at the execution model of kariRS. And in the development of kariRS, it was one of the things kariRS has done is to make its model very similar to what we currently have in the current frameworks. For example, the Arduino framework. I'm just giving Arduino framework as an example because kariRS mirrors a lot about how Arduino works. For example, if you're good in writing Arduino code, you'll basically be able to write kariRS code very easily. You can be able to shift from Arduino to kariRS very fast, actually very fast, because there's the only thing that changes is the language. Is the language that has changed, just coming from one framework to another. Only the language has changed, and that now here you have access to more functionalities, more APIs, and a more robust framework, which is much more safer. So kariRS is based on a loop-based execution model, meaning that you have the two functionalities whereby you have the function that initializes all your code, and you have the loop section, which is where your code keeps learning continuously. But in kariRS, you do not write your own loop. You do not like write a loop. No, you just have this function where you put your code, and that code will be learned continuously. So it's similar to what you see in void loop in Arduino, but here you just have to name your function whatever you want, but you just have to make sure you annotate it with the execution or the application structure for kariRS, and everything will work out well. So applications run on a loop managed by kariRS. So users do not write the main loop themselves, as I've already illustrated. We also have initialization and task are registered once. So you have that section where you write the initialization code once, and it is kariRS takes care of that. The framework handles the execution flow. So everything is handled by kariRS under the hood. So this results in simpler and more predictable programs. So what does kariRS support currently? Hardware support. So kariRS provides safe abstractions for GPIO. So You don't have to do a lot of work. kariRS provides safe abstraction for GPIO, PWM, I2C, the SPI, serial, and also timers. We also have EEPROM. It's actually explicitly, if I could explain about the EEPROM support that is in kariRS, it is quite heavy. This heavy support on how kariRS helps you deal with EEPROM. You can be able even to store structured data at a very easy way. If you look at the documentation for kariRS and how the examples have explained it, kariRS has indeed done a lot to implement how you do EEPROM write and leads and erasing in this framework. When working with your microcontrollers, you can do a lot with the EEPROM. You can store a lot of data and format it in a manner that is quite well, enabling you to store data that such that when your MCU is off and you turn it on again, you can still find your data in a more structured way and in a very easy way to deal with the EEPROM, making sure that even a beginner in the embedded ecosystem can deal and work with EEPROMs. You also have the serial. It's easier to read, to have serial reads and all that. It's very easy, similar to what we see in frameworks or advanced frameworks like Arduino. So all interactions are designed to be Rust idiomatic and memory safe. So kariRS based on Rust, it follows and enforces Rust safety. And so you will also have this advantage of what we see in the Rust compiler, how it is able to point to you if you've done a mistake in writing the code or something, how the Rust compiler actually points to you where the error is. You get that advantage here, right? Because you're almost under the hood using the Rust compiler. And also, again, kariRS has a high level of abstraction of enabling you to pinpoint where the error is when you compile your code. So it is indeed very nice. And this has been quite supported and made possible by something called kari macros. kariRS has this crate known as kari macros, and we also have the kari hall. All these work together to give you a very amazing framework for you to write your embedded code. So this is the other feature that you get from kariRS out of the wood without having to install any other thing, any externals or anything. You get built-in scheduling. So sometimes back we had this library that I built back then for the Arduino ecosystem that is known as Kari, and Kari was basically this library that came to like we want that came to solve the issue about scheduling. Like you have the Kari async, and it came to solve about the scheduling of task. So for you to do that in Arduino, you either have to write a lot of algorithms for you to maintain that, to write your own logic, or you have to use the Kari Arduino library, which is again part of the Kari ecosystem. But again, now this kariRS being a framework provided and under the Kari, it comes with all this functionality under the hood. You don't have to install any external library. You get access to the scheduler, to all these stuff and task scheduler, and this makes your code much more better and safer. That means you can be doing things like LED chasing at the same time you are reading data from sensors, and all this works correctly without any interruptions. This is what kariRS enables for you to do. Just think of it, there's no delays in your loop code. You are reading sensor data at the same time you're doing an LED chaser circuit, at the other time you may be even be rotating motors, and nothing is actually interfering with the other because of how this scheduler that is in kariRS schedules the task. And remember, most of the MCUs you're using, most of them are one core, so you can just think of how kariRS makes it easier for you. So it has an integrated scheduler and support for asynchronous tasks, as I have explained. So this one is designed for embedded constraints. So the other thing is about the project configuration. So kariRS also provides you with a file known as kari.toml file, and this is where you do the configurations for the kariRS projects. So projects are configured using a simple kari.toml file, where you can do the target board selection, the boardlet and port configuration, programmer options, and also we have the dependency declarations, which will be again implemented as times goes on, as kariRS grows bigger. This is the section where you'll be adding new libraries. But again, this file is generated automatically for you with all the configurations once you build a new project in kariRS. This one is provided for you automatically, so you don't have to think a lot about it. The only time that you deal with this configuration file is when you want to change certain configuration. And again, kariRS provides commands from its CLI on how to update and interact with this or this kari.toml file, or else you can edit it manually. But again, kariRS CLI provides you with commands to interact with this file so that you do it in a much more safer and uh, structured manner. So this keeps configuration explicit and readable. You can be able to know this project was built for which board. So this is the good things about kari.toml, or about the kariRS itself. So you can, by looking at this configuration file, which is not is easy to read, you can be able to know this project was built for which actual board, for which MCU. Was it the Mega? Was it the Atmega 2560 or the Atmega 320? You can be able to know which actual MCU this project was built for, because again, each MCU has its own architecture. So the other thing is to look what are the currently supported boards at current. What boards are supported by kariRS? So currently, kariRS currently targets AVL microcontrollers, and this is bound to change, because kariRS is also aiming to expand to other microcontroller families. But at first, kariRS currently targets AVL microcontrollers, and currently it supports Arduino Uno, Arduino Nano, Arduino Mega 2560, Arduino Pro Mini, Arduino Leonardo. All these, actually, if you can check Uno, Nano, uh, Pro Mini, all these ones, they use the same MCU. The Atmega 328P, the Arduino Mega 2560 uses the Mega 2560 MCU. The Leonardo uses the Atmega that use something. So all these ones, these MCUs are supported by kariRS. These are just the dev boards which are supported by kariRS, but under the hood we know that we have various families of MCUs. So boards sharing the same MCU use a common hall. For example, the Uno and the Nano, you can just initialize it with the Uno or a Nano, it will work because they are using the same MCU. So that's basically what you're saying. So kariRS currently targets AVR micro. How to get started in kariRS? So basically, to get started in kariRS, you first have to download it from the GitHub repo. Then follow the instruction given to add the CLI to your system path, and then you open your terminal, and the first command, and this is very important to note, as it is very well illustrated in the documentation. Once you install kariRS, before even thinking about building a new project, the first thing that you need to do is to learn this command, kari doctor. In your terminal, you need to learn this command. You can either write kari doctor or write kariRS doctor. Kari doctor is just shorter than Lighting kariRS, and that's why it is just more idiomatic and easy to just write kari doctor than kariRS doctor. But that's something of is also there. You can write kariRS doctor; it will still work as Lighting kari doctor. So this command has one functionality it does. First, it checks whether you have the dependencies that are required for kariRS to work. One of the dependencies, you need to have Rust installed into your system. You need to have Cargo installed into your system. You need to have something like AVL installed into your system. So all those dependencies are needed for kariRS to work. So again, you don't need to go downloading them from the official website or whatever. So when you run kari-doctor, it checks whether they are installed. Now, if they are not installed, kari-doctor goes ahead and installs them for you into your system. So this is what kari doctor does. That's why it is the first command you need to run after installing kariRS, so that it can ensure that everything lands correctly. Now, once Kari Doctor has landed correctly and it has uh, prompted you that you are ready to get started with kariRS, now from there you can just move on and build your project. Examples are included to help you start quickly. You can look at various examples in the GitHub repo, or also when you download the kariRS, we have a folder with examples file which you can run. So that's it about kariRS, and it's as I finish, I want to say that kariRS is basically a modern approach to embedded development in Rust, and it will do you a great benefit to understand how kariRS works and how to use it. Actually, kariRS is the first product from Kari that is that has provided all its source code, like how all its implementation are in the kariRS GitHub repo. If you look deeply, it has provided you with that, so you can look and understand how kariRS works, and this will boost you a lot in the embedded ecosystem space as kariRS uh, continues to develop. So any feedback, uh, experimentation and contributions are indeed very welcome. If you feel like, you know, this kariRS, I would like to be part of it, I would like to be part of building it, you are welcome to reach out to me, and all that. The feedback when you're using kariRS is also welcomed. You can reach me via the email provided in the GitHub repo. Down there in the GitHub lip of kariRS, down there you'll find the actual email in which you can contact me with concerning kariRS, or any issue or any concern that you have about kariRS, or any question that you have about kariRS. And again, as you can see, that's the GitHub repo, github.com/Vincent kariRS. I am the author and the builder of kariRS and the Kari ecosystem. My name is Vincent Moedi Karimi, and thank you so much for listening. And I hope, and I would love to see what you build with kariRS. Till then, bye bye.